Hello and welcome. Have you ever wondered how scientists can identify unknown substances or figure out the molecular structure of a material? Two incredibly powerful tools they use are FTIR and Raman spectroscopy. They might sound complicated, but today we are going to break down the key differences between them in a simple, easy-to-understand way. So, what really sets these two techniques apart? Let's start with the most fundamental difference, the principle of how they work. FTIR, which stands for Fourier-Transform Infrared spectroscopy, is all about light absorption. Imagine you shine a broad range of infrared light onto your sample. Specific molecules will absorb specific frequencies of this light, causing their chemical bonds to vibrate, like tiny springs stretching and bending. The FTIR instrument measures which light frequencies get absorbed, giving you a unique chemical fingerprint of the molecule. Raman spectroscopy, on the other hand, is all about light scattering. In this technique, you hit the sample with a powerful, single-color laser. Most of that laser light just bounces off unchanged, but a tiny fraction of it gets scattered back with a slightly different frequency. This change in frequency is called the Raman effect, and it also provides information about the molecule's vibrations. This core difference leads to our second point, what they are good at detecting. FTIR is fantastic at seeing vibrations that cause a change in the molecule's dipole moment, making it very sensitive to polar bonds. This makes FTIR a champion for identifying functional groups like OH in alcohols and water, C equals O in ketones, and NH in amines. Raman is essentially the opposite. It excels at detecting vibrations that change the molecule's polarizability, which is how easily the electron cloud around the molecule can be distorted. This makes it perfect for analyzing nonpolar or symmetric bonds, like the carbon-carbon bonds in diamond or polymer backbones, and sulfur-sulfur bonds. Our third major difference is how they handle samples, especially water. Water is a huge problem for FTIR because it absorbs infrared light very strongly, which can completely overwhelm the signal from your sample. This means samples for FTIR often need to be completely dry. Raman, however, barely sees water. Water is a very weak Raman scatterer, which is a massive advantage. You can easily analyze samples in aqueous solutions, like biological specimens, or measure chemical reactions happening in a beaker. You can even measure through glass or plastic containers. However, Raman has its own kryptonite, fluorescence. Sometimes, the laser can cause a sample to glow brightly, and this fluorescence can completely drown out the very weak Raman signal. So, to summarize, FTIR measures absorption and is great for polar groups but struggles with water. Raman measures scattering and is great for nonpolar groups in aqueous samples but can be hindered by fluorescence. Because of this, they aren't competitors, they are perfect partners. A molecular vibration that is weak in FTIR is often strong in Raman, and vice versa. Using both techniques gives scientists a much more complete picture of a material's chemical identity. I hope this simple breakdown helps you understand the key differences between FTIR and Raman spectroscopy. Thank you so much for watching. If you found this video helpful and learned something new, please consider giving it a thumbs up and subscribing to the channel for more science explanations. Don't forget to hit that notification bell so you won't miss the next video. Your support truly helps us grow and create more content like this. Thanks again, and see you in the next one.